Hello friends, welcome to Electrical Design Engineering YouTube channel. Today is our lecture number 15 of our free course, Etap. In the previous lecture, we have seen the selection of cable size calculation. And in today's lecture, we will see the transformer sizing using the Etap. Before starting in today's lecture, please subscribe the channel, like and share the video on your social media profiles. In previous lecture, we have studied about the cable size calculation, and in the cable size calculation, we have taken the derating factor into consideration, calculated the derating factor of the cable. Now, I will show you how this derating factor, how the Etap is calculating this derating factor of a cable. I have forgotten in the previous lecture to show you how Etap is calculating why the Etap is taking these values. In today's lecture, I will show first of all how the Etap is calculating the derating factor, and then I will go to our lecture, that is transformer sizing using Etap. This is the example which we have studied in the previous lecture. When you double click on the cable and go to capacity page, here you will see this is the derating factor. It is calculated here, the derating factor. Now, we will see how this is calculated by the Etap. We go here from correction factors and click on the correction factors, and you will see there are different correction factors for ambient temperature, gripping, short time delay duty, soil thermal resistivity, protective and installation, thermal insulation, and depth of the layer. All the things are correction factors are here mentioned. You can multiply these correction factors, and after multiplying whatever the result you will get, you can multiply this with the base, and you will get this the derating factor. Now, why these values the Etap is taken? Why from these values Etap is taken? Actually, this Etap is taken these values from the tables of IEC 0502. I will show one of you. 1 minute. This is the derating. This you can see here. First of all, we see correction factor for ambient temperature other than 20 degrees Celsius. This is the ambient temperature of the, you can see here, this is the ambient temperature other than 20 degrees Celsius. Here the correction factor is mentioned, and we have taken here the ambient temperature 40 degrees Celsius. And for 40 degrees Celsius, the correction factor is 0.85. So now we will check from the Etap what the Etap has taken the value, whether he has taken 0.85 or other than that. You will see here ambient temperature 0.85. Ambient temperature correction factor is 0.85. Similarly, we can check one more. We can go here. Correction factor for depth of laying other than 0.8 meters for tightly glued cables. For a 1 meter of depth, for 3-core cable, it is 0.98. Now, we will see what the Etap has taken. Etap has taken depth of 0.990. Same, whatever the mention in the cable, the Etap is taken here. In this way, you can now have an idea how the Etap is calculating these correction factors. These tables which I show, these are the tables which has taken from the IEC 60502. Now we will shift to our today's lecture, that is the transformer sizing using Etap. Standards INSI C57, IEC 60076, and IEC 60076 standards provide a set of guidelines and derating factors to be used to determine the size of a transformer. The transformer sizing calculation method used by the Etap software considers various factors. First is the type of transformer, whether the transformer is a 3-phase transformer or a single-phase transformer. Second is the ambient temperature. For air-cooled transformer, use the ambient temperature of air, and for oil-cooled transformers, use oil as a temperature of oil as an ambient temperature. Third, in the altitude. It's the altitude at which you are installing the transformer. The derating factor starts from above 1,000 meters. Below 1,000 meters, up to the 1,000 meters, do not consider the derating factor. Cooling stage. What type of cooling you are providing to the process, whether it is oil natural, air natural, air forced, and any other cooling system if you are using, you have to select from the Etap. There's type of transformer, whether it's a dry type of transformer or oil type of transformer. Expected future growth, what growth you expecting in the future transformer sizing also gets affected with this parameter. Transformer impedance and BIR. Basic insulation BIR means basic insulation level, and transformer impedance also affects on the size of the transformer. Load, whether you are designing the transformer for connected load or a operating load, you know the connected load is greater than the operating load. Load factor also plays a very important role in the size of the transformer. This is the window of a transformer winding transformer editor. Here you can see this is the transformer loading section, in which you have to enter the MVA rating, operated load, connected load. And this is the load variation. You have to growth factor, load factor enter. And this is the installation, whether you are what is the altitude of your installation, what is the ambient temperature of your machine, that is the transformer. And this is the impedance, that the basic BIL limit, primary and secondary short circuit current, all these things are here entered here. And this is the optional section, and this is the growth factor for maximum kVA. And this will be the result window. And when you enter the details, you will get here the result, whatever the result is, come from the result calculations Etap is performing, and all the results will be shown here. You can see here, you can get three sizes. One is the larger size, required size, and the other is the smaller size. From here, you can get the percentage impedance and X by R ratios. Okay. In the next lecture, we will see an example and perform the transformer sizing using the Etap. Here we will take the example and perform the calculation. Thank you.